We confirm that you guys can hear me.
We can hear you.
Hear you.
Mm,
We can hear you.
Thank you. Screen now. So today is February 13th, and we should be talking about Lab 8, identification of gram-positive organisms. You should have gotten your unknown results for the first three tests last Tuesday night or early, very early um, Wednesday morning. And you can be working on your unknown project. I have not checked the unknown notes yet today. I hope to do that sometime later today. Any questions about what we're doing? All right. Well, are there any questions about anything before we begin? There's no questions. Let's begin Lab 8. Identification of gram-positive organisms. We're going to be talking about gram-positive cocci, specifically the Staphylococcus, Enterococcus, and Streptococcus. We'll also be talking about some gram-positive bacilli, including families Listeria, Clostridium, Corynebacteria, and Bacillus. There are some video clips in today's lab. And there's some case studies where you have to use a dichotomous key. The objectives for this lab are one, be able to understand the principles and how to interpret the results for the CAMP test, the Bialasculin auger slant test, the SF broth test, and the optogen sensitivity test. And then two, be able to use dichotomous key to solve case studies involving gram-positive bacterial infections. Any question about those objectives? All right. When specimens are received in microbiology for routine bacterial cultures, they're inoculated on culture media that will facilitate the growth of common pathogens uh, placed in physical environments that will support their growth. And we use media, of course, that would be ones that would be pathogens we find from where we get the samples from. However, the microbiologists can use the gram stain to provide important information about the primary classification of bacteria isolates. However, further biochemical testing is required to identify what is causing the disease. In this lab, we're going to talk about the CAMP test, the Bialasculin hydrolysis test, the SF broth test, and the optogen sensitivity test. Any question about any of that? If not, let's move on to the CAMP test. CAMP is an acronym for the three microbiologists' names who invented the test. So C in CAMP from Christie, A for Atkins, and then MP for Munch Peterson. They first described an amplified hemolytic effect that some beta hemolytic organisms have when they physically grow near Staphylococcus aureus colonies. How you get the CAMP test is you get a blood agar plate and you streak beta hemolytic Staphylococcus aureus down the middle of the blood agar plate in just one streak. Perpendicular to this streak, you then streak another organism, like a test organism or an unknown organism that you're testing to see if it's CAMP positive, perpendicular to the Staphylococcus aureus streak. Let me blow this up a little bit. Sorry, I've got something in my eye for some reason. So here you can see in the, I don't know, off-white color, the Staphylococcus aureus streak, and then you can see beta hemolysis creating a clear zone of hemolysis around the Staphylococcus aureus. And then perpendicular to that, you streak the test organism. Here we have Streptococcus pyogenes, which is, we'll blow that way up, which is beta hemolytic. You have to blow it way up to see that, though. And right there, you can see the streak of the Streptococcus pyogenes, and around it, you have beta hemolysis, where there's a little, very narrow streak of clear zone around the Streptococcus pyogenes growth. The point is, around the Staphylococcus aureus, we have no enhancement of hemolysis. Then when we look at Listeria, you can see slight enhancement of hemolysis where there's like a little arrow from the enhanced hemolysis of Listeria. And once again, you have to blow that way up to see that Listeria is beta hemolytic. You can barely see it. Let me blow it way, way up. There you can see the streak, and right there, very slight beta hemolysis clear region around it, and a larger clear region, kind of like an arrow shape, near the Staphylococcus aureus. And that's called the slight enhancement of hemolysis or slight CAMP test positive. And then here we have Streptococcus agalactiae. And there you see the streak with the slight enhancement in this region of, not slight enhancement, the slight beta hemolysis, where you have a little tiny streak of clear beta hemolysis around the bacteria. And then near the Staphylococcus aureus, we have this humongous arrow, which is enhanced beta hemolysis in this region here. And usually, I'm not sure why, the enhanced hemolysis takes on an arrow-like shape. Any question about any of that? I'm going to shrink this down to normal size now. Yep, a little too far. So there you see CAMP negative right there, a slight positive CAMP test, and then a positive CAMP test. Any question about that? Now, do remember that all of these organisms are exhibiting beta hemolysis. The CAMP test is only looking at enhanced hemolysis. All right, any questions about the CAMP test? If not, let's talk about the bile-esculin hydrolysis test. Bile-esculin agar is a slant used to differentiate between Enterococcus, that family, and Streptococcus family. If the organism hydrolyzes esculin into the product esculatin, a dark brown, almost black precipitate appears. So esculin is actually converted into glucose and esculatin, which is dark brown. If you see dark brown or a very black color, half the tube, then it is positive for the esculin hydrolysis test. If, on the other hand, most of the time it's negative, there's no black precipitate. If there's just a tiny smudge of black, that doesn't count also. It's the hydrolysis of esculin. So that's the esculin positive test, esculin negative test. The negative esculin test will be Streptococcus species, and then the positive esculin test will be Enterococcus species. Any question about the esculin test? All right. The SF broth test is named after Streptococcus faecalis, which is no longer called Streptococcus faecalis. It is now called Enterococcus faecalis. But this test was started before they renamed the species. And in the old days, how you determine if the species was Streptococcus faecalis from the other members of the Streptococcus family was you ran the SF broth test. Now, Streptococcus faecalis is now Enterococcus faecalis, and you can distinguish between Enterococcus faecalis from the other members. Well, no, the Streptococcus family. You can just distinguish it by using the SF broth test. Any questions about any of that? All right. If the organism grows in the SF broth and ferments the glucose in the SF broth, it'll make acid products. And when that occurs, the pH indicator will change from purple to yellow. So a yellow color in the SF broth is positive, a negative color is purple. Enterococcus faecalis, when it grows in the SF broth test, will be positive, meaning yellow. And then if you grow Streptococcus, any species of the family Streptococcus, in the SF broth test, it will be purple or negative. Any question about the SF broth test? Which I guess we should call it the Enterococcus faecalis broth test, but we don't. It's still called the Streptococcus faecalis. And they just usually call it SF broth test, so they're shortening the name. All right, let's talk about the optogen sensitivity test. The optogen sensitivity test is used to differentiate Streptococcus pneumoniae from other alpha hemolytic streptococci. So you have um, something growing your blood agar plate, and you know it is of the family Streptococcus. If it shows alpha hemolysis, you can run the optogen sensitivity test by taking the bacteria, streaking it out on the blood agar plate, and then putting a paper disc saturated with the optogen antibiotic. And if it is optogen resistant, meaning there's a zone of inhibition less than 14 millimeters, or there's no zone of inhibition as this one, then it is optogen resistant, and it will be a member of the Streptococcus family, which is creating alpha hemolysis, but it is not Streptococcus pneumoniae. If, on the other hand, the optogen sensitivity test is positive, meaning it has a zone of inhibition greater than or equal to 14 millimeters, then it is Streptococcus pneumoniae, assuming there's an alpha hemolytic pattern on the blood agar plate, and you know it is a member of the Streptococcus family. Any question about any of that? All right. So this test cannot be used if the hemolysis on the blood agar is beta hemolysis or gamma hemolysis, but only if it is alpha hemolysis. All right, microbiologists use dichotomous keys that describe tests that could be performed. They illustrate how to arrive at a logical solution using a methodological thought process called dichotomous logic, where, for example, you have all your possible species, and then you run the gram test. You can separate all the possible species into those which are gram positive and those which are gram negative. assuming that it's gram positive, we then scratch out the gram negative. And then we can run another test looking to see what the shape of the bacteria is, its morphology. Is it a bacillus, gram-positive bacillus, or is it a gram-positive cocci? If it's not a bacillus and it's a cocci, then we go this way. We can scratch the gram-positive bacillus out, and then we can run the catalase test. Once again, that separates the bacteria into two possibilities, and that would be catalase positive. The member of the Staphylococcus family is catalase positive, or it can be catalase negative, in which case it can be the family Streptococcus or the family Enterococcus. Since it's gram positive, we can scratch out the, excuse me, not gram positive. Since it's catalase positive, we can scratch out the catalase negative. And then we can run the coagulase test. If it is coagulase positive, the species is Staphylococcus aureus. And if it's coagulase negative, it is another member of the family Staphylococcus, but it is not Staphylococcus aureus. You can then run the novobiocin test, and it is if it is novobiocin positive, let me see if I can read that, because it's a little bit written over. It is Staphylococcus epidermidis if it's novobiocin positive. If it is novobiocin negative, it is Staphylococcus saprophyticus. And that is running a dichotomous key, where you have a test which separates all possibilities into two groups. Now, I will warn you that they consider it dichotomous logic if you have a example like the PR test, which can separate it into three different groups, such as you can separate the possibilities into AG, acid and gas production. You can separate it into just A, meaning acid production, no gas, or you can have a negative result. Any question about doing a dichotomous key? Yep, a little too far. All right, you're not going to be physically performing any of these activities because everything we do will be done online. However, you will be held responsible for knowing how to perform and interpret the tests in this lab, including in the lab module. We do have some video clips on running the SF broth test and the bile esculin test, and then another video on the CAMP test. So watch those videos. And then let me go to the worksheet. And then for question number 2, fill in the table. The first one has been done, filled in for you to explain how to do it or help explain how to do it. And that is for the gram stain for both cocci and bacilli. If it is a positive result, meaning gram positive, the color will be purple. So you would write in the positive result. For a negative result, gram negative, the color will be pink. So you would write in pink. So do that for what are the results of the positive test for the Schaefer-Fulton stain for endospores, and then write in the results for the negative result. If you need to, like for this, you probably can do it in a single word, but for the capsule stain, you kind of have to put in a few words, at least, if not a sentence, in which case you can expand the column and add your discussion. You could also write it, if you need to, down here, if you need more space. Just state for the uh, capsule stain, which is using the negative stain to determine capsules on the cell. Uh, the positive result will be, and then the negative result will be. For the catalase test, using the reagent hydrogen peroxide, state what the positive result is and what the negative result is. For the coagulase test using rabbit plasma, state what the positive result is and the negative result. For the oxidase test, what the color of the reagent will be, positive result, and what the color will be, a negative result. For the camp test, you got to kind of explain it here, but you could say something like enhanced arrow and then negative result, negative arrow. For the biolisculant hydrolysis test, you can give the color of the positive result and the color of the negative result. For the SF broth test, you give the color of the positive result and the color of the negative result. For the optogen sensitivity test, give the positive result, which is more than just a zone of inhibition. You have to say what the size of the zone of inhibition is. Let me go to the lab module there. And which one is that? Is the oxygen sensitivity test. So you have to say for positive that it's 14 millimeters or greater. And then for the negative result, you have to say less than 14 millimeters or no zone of inhibition. Go back to the table now. And then give the base titration sensitivity test, similar to the optogen sensitivity test. Positive result, and then the base titration sensitivity test, negative result. For the base titration sensitivity result, I don't think that one is given in this lab module. Let me look at that. It's not given in this lab module. We have talked about it in an earlier lab, and so you can either look that up in an earlier lab module or you can look up it online, either way. Or I guess you could use your AI to get the answer. Remember, if you use the AI for anything, just state uh, where you got it from the AI. Otherwise, it's plagiarizing the AI. And then for question 3A, this shows you a video of how to develop and use a dichotomous key. You do not need to construct a key for this class. However, this video will help you understand the general behind the idea. If you're comfortable with a dichotomous key, how to make one and how to use it, you do not need to view the video. But if you're uncomfortable and you need a little practice, you should view the video and go through that. And then for 3B, you're going to open up the dichotomous key for this lab. Let me show you where that is. Slow today, which is kind of surprising. Maybe it's because everyone's from Clark College is going on the internet because Clark College is closed. Um, Can I go past it? There it is. So in week 6 lab, here's the dichotomous key here. Open it up. I probably should download it because it'll display better. Yeah, let me download it. Oh, now I don't have it anymore. Let me go here. We have a dichotomous key looking at the gram stain. We have gram-positive cocci following here, gram-positive bacilli following here. The bacilli continues on page 2, I think. So there's the gram-positive bacilli, which you can separate into anaerobes and aerobes. You can then separate it into endospore positive production, endospore negative production. If it's endospore positive by the dichotomous key, be a member of the Bacillus family. If it is endospore negative, it can be either Listeria or Corynebacterium species. And then you can separate those out by the beta hemolysis test and the CAMP test. So we're looking at two tests. And if it is uh, weak positive, it'll be Listeria monocytogenes. And if it is negative for the hemolysis test, gamma hemolysis, and probably negative for the CAMP test as well, it's Corynebacterium. And then we don't separate it further than that. All right, let's go back to the cocci. After you have the cocci, you can then split the cocci into those which are catalase positive and those which are catalase negative. I'll go with the catalase positive. You can then run which will be Staphylococcus species, and then you can do the coagulase test. If it's coagulase positive, it's Staphylococcus aureus. If it's coagulase negative, it'll be either Staphylococcus epidermidis or Staphylococcus saprophyticus, and we're ignoring other members of the Staphylococcus family. And then you can separate these two out by using the Nova-Bayesian test. Any question about any of that? Let me state here on the catalase negative, it's not telling you what this test is, but it's gamma, beta, and alpha. This is the growing the culture on blood auger and then looking at the hemolysis pattern. So that would be gamma hemolysis, beta hemolysis, and alpha hemolysis. Any question about any of that? All right, so you need to use this dichotomous key for this lab only. Don't use it for your unknown report, for example, or any other lab. And you can use that dichotomous key for the questions in the lab exercise, which will be one of these species. It may even be further, like if it knocks down the Clostridium and Listeria species. Then use the dichotomous key to answer the question for what are the identity of the species causing the gram-positive bacteria of case study 1, and list the species name here for case study 1. Now we've got to go back to the lab module to find the case study. Oh, no, you don't. It's not in the lab module. It's in the case studies are below the worksheet for Lab 8 and below the lab module for Lab 8. So there's case study 1. Open it up. It goes through the case study. A 13-year-old teenager attended a week-long summer scout camp. Upon returning home, his mother notices a pustule beginning to develop in a spider bite on his arm. The area is warm to the touch and is becoming extremely painful. When her son starts running a fever, she takes him to a walk-in medical clinic for evaluation. The physician orders a gram stain of the exudate and a routine culture. Here are the initial findings. So there's the pustule, there of the spider bite. There's the gram stain, and this is showing you his cells, the very big red cells, and then the bacterial infection there, which, let me see if I can blow that up. the bacteria there. You can determine what the shape is. You might even notice the growth pattern. That's not terribly critical, but the gram stain positive and the his own cells are gram negative. Let me shrink that down now. And then the bacteria were grown on blood agar, shown over here. And you can see the uh, hemolysis pattern here. And then they did the uh, catalase test by using hydrogen peroxide, putting in the bacteria, and there's the result of the catalase test. And then they did the coagulase test by putting in rabbit plasma in the cells, and there's the result of the coagulase test. And then this is a further test, which isn't discussed in the lab, but you can, there's the mannitol salt agar test in your unknown project, so you can look up mannitol salt agar. I think we talked about mannitol salt agar in a previous lab. And then it shows you the growth of the bacteria on a mannitol salt agar, and then the coloration of the mannitol salt agar. And then answer what bacteria species was isolated. Any question about any of that? I'm not going to go through all of them, but I will go through case study 2. Let's close that down. In case study 2, we have a 27-year-old female receiving prenatal care. At the end of her last trimester, she came into the doctor. The doctor ordered a routine vaginal culture. She's not exhibiting any signs or symptoms of infection. And when they took the bacteria and then streaked it on the blood agar, you can notice the hemolytic pattern on the blood agar. And then they did further tests on this bacteria. And there's the gram stain. You got to blow it up to see it. You can see the color, so it's um, you can determine whether it's gram positive or gram negative. But if you blow it up, you can actually determine the shape right there. Let me shrink that down now. And then they ran some further tests. So they took the bacteria growing on the blood agar and did the catalase test. And there's the result of the catalase test right there. And then they did test 2, which is, I believe, the novobiocin test. Let me make sure that's correct. I've got it written on here. Test 2, sorry, it's not the novobiocin test. It's the base tracing sensitivity test. Base tracing sensitivity test. And then they did a test 3 where they did the camp test, streak the bacteria here. And as you can see, there is a camp result right there. So state the camp result and then look on the dichotomous key to determine what bacteria was isolated. Any questions about the case studies or how to answer um, the case studies? All right, so you guys go ahead and get started on the lab. I will be here until 3:30. Actually, I'll be here until 4 o'clock, or the last student logs out. Lately, most students have been logging out early. So if you have any questions and you want help on this lab, make sure you ask it before the last student logs out, because once the last student logs out, I'm going to log out as well. All right, any questions about the lab? If not, go ahead and get started on it.